to your favorite intermediate algebra course. We're going to take a look today at graphs of rational functions. Going to continue on with this. So a rational function, here's your formal definition, where you got p of x over q of x, where p of x and q of x are polynomials as shown there with those expressions, okay? Now what we're going to take a look at is our vertical and horizontal asymptotes. You may want to pause this for a minute and write this down because we're going to come back to this as we progress through our examples, okay? So the first example we're going to look at is graphing a rational function where the degree of the top, m, is less than the degree of the bottom, n, okay? And the first thing I like to look at when I'm graphing these things is I like to consider what are my vertical asymptotes? Where is this thing undefined, okay? So you look at your denominator, x squared plus x minus 2. You say, where would this thing be undefined? And you just go ahead and you factor that thing. You say, oh, okay, -2 and a 1. Okay, so you go ahead and you put that on your graph. -2, I'm going to have a vertical asymptote and an x value of 1. Okay, so there's my two vertical asymptotes. Okay, so that's where your x value is undefined. So this is really going to affect your domain. Okay, now the second thing you want to look at is your horizontal asymptote. Okay, so your horizontal asymptote, you have to consider your degree for this. Okay, so let's look at the degree of the top. You see the 4 there? Well, what is the degree of the top? There's no x value, right? Well, they don't write this in, but it's x to the 0. Remember, anything to the 0 power is 1. So this is kind of like 4 times 1, right? So the degree of the top we call m. The degree of the top is 0. The degree of the bottom, you see the 2 there? Degree of the bottom is 2, okay? So m is obviously less than n, right? So if the degree of the top is less than the degree of the bottom, let's look at it right here. If that occurs, if m is less than n, then the line y equals 0 is a horizontal asymptote. Okay, y equals 0 would be your horizontal asymptote. So you immediately write that, y equals 0. And let's talk about that for a minute. A horizontal asymptote means as your x value goes to positive infinity or negative infinity, what's the y value that you're approaching? So if you think about plugging in an incredibly large x value, like let's say we plug in 1,000,000 for our x, right? So we'd have 4 over 1,000,000, this huge million squared plus 1,000,000 minus 2, right? So we have this huge number in your denominator. Well, what's 4 over a huge number? That's essentially 0, isn't it? So that's why you're approaching at your extremities here a y value of 0. So let's put y equals 0. Let's put that horizontal asymptote on there, which is your x-axis, y equals 0. And now from here, you're just point plotting. Okay, you just plug in some points. So let's do that. We got XY table, we got y equals 4 over x squared plus x minus 2. Is that what it was again? Yeah, 4 over x squared plus x minus 2. So let's plug in some stuff to the left of that -2 vertical asymptote. So like -3, -4, -5, a few of these, till I kind of start seeing a pattern. Okay, so we plug those in one by one. Let's plug -3 in, and we won't do every one of these, but you can, because I'm sure you can do the arithmetic to plug those in. So 9 minus 5 is 4. So you got 4 over 4 or 1. So when x is -3, you got a y value of 1. So -3 comma 1. I'm going to put that on there. Okay, you plug in -4 the same way. I'm going to cheat. Plug it in here real fast. So -4 is going to spit out -0.4, -2/5. Okay, you plug in -5 the same way. 0.2 repeated, it looks like. -6, 0.143, 143. You could keep going if you wanted to, but let's put those on our graph here. So -4, -4, and it looks like I'm at -0.4. I'm sorry, positive 0.4. What am I talking about? That was positive 0.4. 1, 2, 3, 4. Positive 0.4, so 4/10 of the way up. Negative 5, I'm only 2/10 of the way up. Negative 6, I'm even lower, negative or positive 0.143, and so on. You can kind of see behavior of that thing, right? Of course, a vertical asymptote means as you approach that -2 value, it's either going to shoot up to positive infinity or maybe it shoots down. But you can plug in -2.5 if you cared to, and you'd see, you know, if you plugged in -2.5, you'd get 2.286. You know, 2.5, and I'm up here at -2.286, right there. So, okay, so enough points there that you kind of got a feel for what it's doing to the left of that vertical asymptote. Now you want to plug in some points in between the two vertical asymptotes. Okay, so between -2 and 1. So let's plug in -1, let's plug in 0. We can't plug in 1, so let's plug in like 0.5. So plug those in one by one. You plug in -1 and you get -2. You plug in 0 and you get -2. You plug in 0.5, get -3.2. Let's plug those in. -1, -2, 0, -2, 0.5, -3.2. Like, boy, this is kind of interesting, huh? Why don't we plug in -1.5? So what's going on between -1 and -2? And it looks like -3.2. Okay, so -3.2. So it looks like this thing's going to kind of shoot down and probably somewhere in between there, it kind of maxes out there. Then it goes down here, okay? And I'll actually, let me give you that point where it maxes out. Highest Y value there, if you will. It's -0.5, -1.778. Okay, that's the highest point right here. Okay, and I just used the max feature on my calculator. Okay. All right, now over here. See what's going on over here to the right of 1. So maybe 2, 3, 4, a few of these points to get us going here. 2 gives you 1. 3 gives you 0.4. 4 gives you 0.2 repeated. 5 gives you 0.143. And so on. So 2, 1, 3, only up 4/10 of the way. 4, I'm only about 2/10 of the way. So on. Of course, you could plug in some between 1 and 2, like 1.5, just to verify that that thing's higher, 2.286. Okay. Looks like kind of like that. Okay. So now let's talk about the domain and range. Okay. So you've got this thing all set up here. And your domain, okay, let's talk the domain. So left to right, so you see how you're coming along on this graph, right? And then you have that break at -2. Okay, so our domain, let me do this in interval notation. I say from -infinity, from left to right. So from -infinity up to -2. Now, do you touch an x value of -2? You do not. So we put a parenthesis. And then we're also between -2 and -1. You see this junk in here, right? So we're between -2 and 1. We encompass all those values between -2 and -1. We never touch -2. We never touch a positive, I'm sorry, -2 and +1. We never touch a positive x value of 1. And then we take off again from an x value of 1. And we go as far to the right as we can, right? We just keep, well, we keep going forever, okay? Now let's talk about our range here, our range, okay? So if you notice, we're encompassing all these y values on the graph, right? Because this thing keeps going down and so on. Okay, so we're encompassing all those y values up to where? Well, up to that point, and I actually gave you that point. It's a y value of negative 1.778. So we're coming from negative infinity up to that negative 1.778, okay? And do we touch it? Yes, we touch that y value, okay? So I put a bracket there, it includes it. And then you notice this horizontal asymptote, right? And we never, in this case, we never touched that horizontal asymptote. And by the way, you can cross horizontal asymptotes. At times you will have some odd or some interesting functions that do that, okay? So we take off from 0, but we don't touch the 0, and then it goes as high as we can see. You see how these things just keep going up, up, up? Okay, so the range is a set of y values there. So that's our range for that one. All right, let's look at graphing a rational function where m equals n, like this one right here, y equals negative x squared plus 4 over x squared minus 1. Okay, let's talk first about the vertical asymptotes here. Okay, so let's take that denominator and say this is where if x squared minus 1 equals 0, we are undefined. All right, so what are the equations? What are the equations for your vertical asymptotes? And you factor it, set it, use a zero product property, and soon enough you got your equations, don't you? So we got 1, x equals 1, x equals negative 1. Okay, there's our vertical asymptote. So that's a big hint for your domain as well. Okay, now let's do our horizontal asymptotes. Let's do this a little bit. Well, no, change my mind. Go up here. Let's do our horizontal asymptotes. Okay, so we look at the degree of the top. You notice the degree of the top is 2, degree of the bottom is 2. So the degree of the top, 2, degree of the bottom, 2. Oh, looks like m equals n. M equals n. So you look back here and you say, well, if they're the same, so I'm looking right here. If they are the same, if the degree of the top is equal to the bottom, then the line y equals a sub m over b sub n is your horizontal asymptote. In other words, the coefficient in front, the leading coefficient of the numerator over the leading coefficient of the denominator. Okay, so leading coefficient numerator over leading coefficient of the denominator. Here we go. Let's see what it is. Y equals, what's the leading coefficient? Negative 1 over positive 1. Negative 1 over positive 1. So y equals negative 1 is our horizontal asymptote. Let's put that on there. See it right there? Y equals negative 1. So if the degrees are the same, take the leading coefficients, that's going to be your horizontal asymptote. Okay? If you think about that, if you plug in an incredibly large number, like a million, we'll say, and you plug it in for x, right? You got a million squared, and then you apply the negative in front, so whatever a negative a million squared is plus the 4, well, that plus 4 really doesn't make a whole lot of difference because you're dealing with such a big number already. And then you divide that by that million squared minus 1, and again, that minus 1 is so negligible that you really have negative a million squared over a million squared, which is essentially negative 1. So at your extremities, you're approaching a y value of negative 1. Okay, that's why you got that horizontal asymptote there. Okay, and from here, like you would probably suspect, you're just going to plug some points in. Okay, so we got y equals, no, I forgot, negative x squared plus 4 over x squared minus 1. And we're going to plug in points to the left of negative 1, to the left of that first vertical asymptote, so negative 2, negative 3, negative 4, until we get a feel for that, right? Plug some in between the vertical asymptotes, plug some into the right. Okay, so let's plug in negative 2. So negative 2 squared, negative 2 squared minus 1, negative, that's 4. We got 4 minus 1, negative 4 plus 4, 0 over that 3, 0. So negative 2, comma, 0. Put that point on there. Negative 3. So negative negative 3, sorry, squared plus 4 over negative 3 squared minus 1. So we got negative 9 plus 4 over 9 minus 1, so negative 5 over 8. So negative 5 eighths, negative 5 eighths, so negative 3, and we're 5 eighths of the way down. Okay, negative 4, and we keep doing a bunch of these. I'm going to cheat and punch it in here. Trace them. So negative 4 ends up spitting out negative 0.8. So negative 4, 8/10 of the way down. Okay, you see how you're getting closer and closer and closer to that y horizontal asymptote, that y value of negative 1. And this is going to shoot up. Okay, of course you could plug in like negative 1.5 and verify that. Okay, so now let's plug in some points between those two vertical asymptotes. Okay, so plug some in. Now our two vertical asymptotes are negative 1 and 1. So definitely we're going to plug in 0. Then you want to know what's going on between 0 and 1, so maybe a half. Want to know what's going on between 0 and negative 1, negative 0.5, and so on. Okay, so 0, you stick that in, you got negative 4. So 0, comma, 1, 2, 3, 4, negative 4. Again, between 0 and 1, so 1/2 we plug in, we get negative 5. So halfway we got negative 5, negative a half. Looks like it spits out negative 5. You could put some more in there, and soon enough you're gonna see that. Okay. Now to the right of 1. So 2, 3, 4, many as you need there. Plug those in one by one. So we got 2, 0, 3, negative 0.625, got 4, negative 0.8 of the way. Anyways, we get a bunch of these points on there. Soon enough, you have it. Okay. So here, let's talk about, can I see that? Our domain is all real numbers except for except for plus and minus 1, right? So everything else in our range here, and we're going to say that that's our max point right there. We're going to say, well, you know what? We're coming from negative infinity up to that y value of negative 4, right? And then we have this break. So I'm going to do this, you know what? I'm going to do this in interval notation. So negative infinity up to that negative 4. Whoops, I should say I include that negative 4. Okay. Union, then we go from, there's nothing between here up until that negative 1. And then from that negative 1, we take off and we go as high as we can, right? But we never, in this case, we never touch that horizontal asymptote, okay? So, anyways, we're over on that, I'll leave it at that. Okay. Take a look at graphing some rational functions where m is greater than n, okay? So again, the first thing I want to look at here, let's talk about the vertical asymptotes, okay? So you got this denominator, where's your denominator? Not defined, x equals 5. Okay, so you got that vertical asymptote. Let's do the horizontal asymptote. the degree of the top compared to the degree of the bottom. Degree of the top is 2, degree of the bottom there is 1. So you notice 2 is greater than 1, right? M is greater than N. So if your M is greater than N, if you look back right here, I'm looking right here. If M is greater than N, you have no horizontal asymptote. Now, it has some end behavior, and if they only differ by a degree, you probably have a slant, you will have a slant asymptote, okay? So this is important to know that the end behavior is the same as that graph, okay? Which is taking your coefficients right here, x to the m minus n. So that's kind of what it behaves like at the extremities, okay? Graph's end behavior here. All right, so let's go back to this. So I say, well, there's no horizontal asymptote. It does at the endpoints behaves like at the end a sub m. Okay, so the coefficient in the front, which is 1, over the coefficient of the denominator, which is 1, and then it's x to the degree of the top. Degree of the top is 2, minus the degree of the bottom, which is 1. So this thing is just 1 x to the 1. Okay, so if you look at, there's your slant asymptote. Okay, so at the extremities, I like to put a little dotted line there if it's a slant asymptote, so where it behaves that way. Okay, but big thing here, no horizontal asymptote, right? And then we're just going to go ahead and we're going to graph a bunch of points, take a look at this thing, and go from there. Okay. That's kind of bugging me here. I don't have any room. Okay, so let's graph some points now. Let's go to the left of 5. So how about 4, 3, 2, 1, 0, and so on. And we're just going to plug those in one by one. Okay, so you plug the 4 in, and you get 0. You plug the 3 in, you get 1. Plug the 2 in, you get 0.6 repeated. Plug the 1 in, you get 0. Plug the 0 in, you get negative 0.8. Okay, let's take a look at those. 4, 0, 3, up 1, 2, I'm up 6/10 of the way. 1, I got 0. 0, I'm at negative 0.8. Okay, so this thing is kind of interesting here. And you could do, between 4 and 5, so 4.5 as well. Make sure that that thing's going down, negative 3.5. 4.5, you get negative 3.5. So this is like that, okay? And remember, as you shoot out to the left, you're approaching that slant asymptote there, okay? Now we got to get some points over here to the right of this x value of 5. So let's 6, 7, 8, 9, as many as you need there. Plug those in one by one. 6 is 0. 7, I'm sorry, 6 is 10. What am I doing? Can't read that. 6 is 10. 7 will spit out 9. 8 spits out 9.3 repeated. 9 spits out 10. Okay, so we got 6, 10, 7, 9, 8, 9.3, a little higher, 9, 9, and you maybe put in 5.5, but anyways, that's kind of what this funky thing looks like. Okay, so that's an example. One example of graphing a rational function where the degree of the top is greater than the bottom. Remember, if the degree of the top is greater than the bottom, you have no horizontal asymptote. You still want to find those vertical asymptotes and discuss you want to discuss any domains and ranges. So let's do that for this one. Your domain here, you see how from left to right, the only break you have is that vertical asymptote at x equals 5. So we are all reals except for at 5, okay? And our range here, and you would have to consider what that is. I don't, if is that the highest point? So I'd use my max key on my calculator. As you notice that there's no y values between here and there, right? So let me name those points real quick. Three, 1 is that highest point, so right there's 3 comma 1. Okay, so we're coming from, I'll do this with interval notation, change it up a little here, negative infinity up to a y value of 1. I include that max point, right? And you notice there's nothing in here. There's no y values in here, right? Nothing. Up until, and this other point, let's see, that minimum value there is 7, 9, so that 9 is the lowest that you hit there. So you take off from that 9 and you go up to positive infinity, right? Okay, so there's your range for that one in interval notation, okay? Couple more quick things, and this is just to involve some transformations. Now, 1 over x is kind of your classic rational function, right? Where we have the horizontal asymptote y equals 0, the vertical asymptote x equals 0. So if you were to take this and you were to just to throw on a 2, how would that change it? Well, it would take that same thing. So the horizontal asymptote y equals 0 is now up 2. The vertical asymptote, of course, shifting that up 2 makes no difference. But everything else looks exactly the same. So this is y equals 1 over x plus 2. Okay, so, oops, I kind of messed that up, but anyway, so that's a shift up 2. Now what if you were to go like this? Okay, you think to yourself, oh, now I got a vertical asymptote at x equals 3. So this has been shifted right, horizontal shift, right 3. 1, 2, 3. Okay, right 3. Still have a horizontal asymptote y equals 0. So all points from the original green function, everything's just been shifted to the right 3. Okay, so don't forget about your shifts and things for these rational functions. They could be of value when you're looking for vertical and horizontal asymptotes and things. Okay, see you guys in class.